We'll proceed in vector summation and integral calculus. Vector summation and integral calculus, in which we are pursuing the discussion, and we are proceeding with very mind-blowing kind of computation that is called bank interest rate. In bank interest rate, we are going through, there are two ways that bank give the interest. I mean, if someone has done fixed deposit in the bank, then if someone goes to the bank, generally it will be written that if you do fixed deposit, this is the rate we are giving. What is the rate? Rate is 7%. Okay, rate is 7%. If you deposit for 1 year, then for fixed deposit. If you deposit fixed deposit for 1 year, you will get 7%. If you fix deposit for 2 years, then you will get 7.1%. If you fix deposit for 5 years, you will get something like or for 5 years 7.2%, like that. This is called fixed rate, 7%, 7.1%, 7.2%. Right side it will be written as annualized rate. Annualized rate. Annualized rate means, now if someone is doing fixed deposit in the bank, then he is getting 7%. Okay. If he is doing fixed deposit for 2 years, then he is getting 7.1% per year. If he is depositing for 5 years or more, then he is getting 7.2% per year. Right side, there will be again one column, and that column would say that effective annualized rate. Effective annualized rate. What is effective annualized rate? For 1 year, 1 year 7%. Effective annualized rate is 7%. 2 years, the interest rate is 7.1%. Effective annualized rate is 7.15%. For 5 years or more, 7.2% is the rate. Annualized effective rate is 7.25 or something like that. Okay, what it is? So bank generally, I believe bank generally, they compute monthly base. I'm not sure, I believe so. Consider they are computing monthly base. Okay, I believe the equity market, they compute things daily basis. Equity market, the interest rate is calculated on daily basis, whereas in the bank it is monthly basis. If bank is doing something else, then someone has to tweak it accordingly. So bank goes with the interest rate. Bank goes with the interest rate, and that is monthly interest rate. What is monthly interest rate? That we will talk. Okay, so bank goes with the monthly interest rate. What is monthly interest rate? If someone is depositing 100 rupees or $100 in the bank, bank is, consider he has done fixed deposit for 5 years, and then for 5 years he is entitled to get 7.2% annual interest. Okay, but it will be multiplied every month. This is what bank is saying. Every month, in a way that if interest rate is 7% for 1 year, then how much it will be for 1 month? 7 by 12%. It will be for 1 month, because interest rate is annualized interest rate. 7 by 12 is the interest rate per month. Now, if he has deposited $100 or 100 rupee, 100 into 7%, that will become 7 rupee or $7. Okay, then it will become 100 and, oh, I'm sorry. If I calculate after 1 month time period, when bank is saying that things are getting updated every month, after 1 month time, person is seeing 100 plus 100 into 7.5. If 7.5 is the interest rate, okay, for the 5 year term deposit. Okay, or let's compute it. Okay, let's go for 5 years. 5 year 7 point or 7 point. Okay, I forgot it. Let's, for 1 year interest rate is 7%. For 2 years or more, interest rate is 7.1%. 5 year or more, interest rate is 7.5%. Let's go in this manner. Now, after 1 month, what is the new value that person has in his account when he has deposited $100, 100 ruble? 100 taka or 100 rupee in the bank. After 1 month, interest rate is 7 by 12, 7.5 by 12 if I had deposited for 5 years. 7.5 by 12, whatever it comes multiplied by 100, whatever is whatever is money is coming, okay, 7.5 by 12, how much it will come? 7.5 by 12, okay, it will come more or less 0.6%. 0.6%. So 100 into 0.6 means 6 rupees. So 106, I'm making some mistake. So 7.5% divided by 12. Okay, that the 7.5% divided by 12, it will come as 0.6%. 0.6% means out of 100 it will be zero point 0.6. Okay, so after 1 month time his money will be $100.6. $100.6 after 1 month time period. Now principal amount will become 100.6, and then for next month 100.6 plus 100.6 multiplied by 7.5 by 12 will be computed over it. Whatever it comes, that will be principal amount after 2 months. Okay, then again for next month, whatever principal amount is calculated, now on top of it, consider the next amount that is calculated is X. After 2 months, his amount, he started with $100. After 2 months, his amount become X. Then X plus X into 7.5, 7.5 by 7.5 by 12 into 1 by 100. That is the amount he will have after end of 3 months. Means things are pursuing monthly basis. Then someone will say, what is meaning of 7% per year? No meaning. We will talk about it. Actually, it does not make any sense. But why you are saying that 7.5% per year when you are calculating per month basis to attract the citizens, to attract the people, because people would not understand monthly basis and by 12 and this so many things. Just see 7.5, but on right column it will be written that the kind of effective annualized rate is 7.8%. Means effective annualized rate is at the end of 1 year, at the end of 2 year, at the end of 3 year, at the end of 4 year, at the end of 5 year. Okay, when you calculate the actual interest rate that will be calculated, that you will see actually it will be 7.8, 7.8, 7.8. There are many banks, they go beyond it. There are many banks, they go beyond it. What is beyond it? Consider that after 5 years, money is becoming zero point 0.7 times. Means $100 will become $170. $100 will become $170. Consider through this interest rate 7.5 per month. I don't know how much it will be. I think so. Probably it will become $170. $170 in 5 years. What is interest rate? Okay, I believe 30, 40, around 14%. They will write effective interest 14%. Okay, or if I say after 5 years, it is becoming zero point 0.6 time more, 60. Then it is 12%. They will write effective interest rate is 12%, 12%, 12%. Okay, annualized interest rate is 7.5. Effective annualized interest is 7.8 because they are calculating per month basis. And then the net interest rate per year is 12%. Why 12%? Because when you deposit $100, it will become $160 in 5 years. Means every year you are getting 12% interest. These are the fascinating thing people would put in there. So people will think, see, bank is showing 7.5%, but I am getting 12%. Means bank is so nice. Means they are so generous anyway. Now, concept that we are bringing here, we have talked in the last video also, that how we can use calculus here. Generally, people They use the algebra here. What is the fundamental? So this is the one thing. If you deposit $100, then per month basis it will get accumulated. It will become renewed. The principal amount that is $100 at the beginning, it will get renewed after every month with interest rate of whatever the annual interest rate is 7.5, 7.5 by 12. Whatever is coming monthly basis, that much the interest that they will give. Now consider that a bank is indeed it is giving annual interest only, not monthly. In monthly you will not get anything. Every year, if $100 is there and 7.5% is interest rate, it will become $107.5 at the end of 1 month, end of 1 year. Then for next year, $107.5 will become principal amount, and on top of it, again 7.5% interest will be given. Okay, then probably it will become $116 or something at the end of 2 years. It will go like that. If someone compute the formula, it will become y amount at any t, y, and in bracket small t bracket close, y as a function over t. What is y? Y is the current money in the account. What is the money in the account right now? That is called y. Y at any t is in year, at any t year equal to a to the power t into y at the 0 at here. A means 1 plus c. C is the annual interest rate. 1 plus C. What is C? C is annual interest rate. What is annual interest rate? 7.5 here. So 1 plus 7.5 by 100, 107.5, that is called A. A is not an entity actually. Actual entity is C. That is the annual interest. So C is 7.5%. 1 plus C is called annualized multiplying factor or growth factor. How it can people can calculate it. At the end of 1 year, how much is the amount person expect, that is 100 plus 100 into C. C is the interest rate. So it becomes 100 and in bracket 1 plus C. Okay, whatever the amount is 100 in bracket 1 plus C. Now after 1 year again that amount plus whatever the amount was again multiplied by C, it will become 100 and in bracket 1 plus C plus 100 in bracket 1 plus C into C. Someone can take out 100 and in bracket 1 plus C outside in the bracket, and inside the bracket it will be 1 plus C again. It will become 100 into 1 plus C square. Means of every year 1 plus C will start attaching to it. 1 by plus C, if I say it is A, that at the end of t years, small t years, yt equal to A to the power t into y. Y at the beginning what I have deposited, that is called the first amount, beginning amount, y0. Okay, I have given example that I have a well-wisher that I don't know, that is called external person. I have a well-wisher that I don't know, external person. He is depositing S amount in my fixed deposit every year that I don't know. Okay, when end of 1 year, 1 year is going, when computer is about to calculate that what is the new amount, that is A into Y, then at the moment he is saying just before that someone has deposited S amount. So net amount after 1 year is A into Y plus S. Next year when computer is going to calculate how much amount he has in his account, then he is calculating A into Y plus S is the amount that is 1 year before. Then after 1 year it will be A into Y means Y0, the amount at the beginning, A into Y0 plus S plus A into Y0 plus S in bracket into A, because A will be the growth factor. Then someone is saying someone has deposited S amount again. Okay, so it will become like A square Y0, A square Y0 plus S into A, because S will get multiplied by A only one time. where y0 will multiply with the a2 times a square y0 plus s into a plus s that someone has deposited at the end. After t years, what will be the amount person would expect in his account? A to the power t y0 plus s, and in bracket a to the power t minus 1 plus a to the power t minus 2 plus a to the power t minus 3 plus a to the power 1 plus a to the power 0. A to the power 0 belongs to the s that he has deposited at the end. Okay. Now what will be the net computation? Then we saw that a to the power t minus 1 plus a to the power t minus 2 plus 1 will become a to the power t, a to the power t come down minus 1 divided by a minus 1. A to the power t come down minus 1 divided by a minus 1. That is the that will become the net sum. So what is the money person is expecting at the end of t years when he has deposited a y0 amount in the account fixed deposit at the beginning only, and someone else is depositing s amount at the end of each year? Then it will become y0 into a to the power t plus s, and in bracket a to the power t minus 1 by a minus 1. Now concept is coming, can we use calculus to compute this full part? If I want full part to have calculus to compute it, then can we use calculus? We have demonstrated this in the past video also. Can we use calculus to calculate the full part? Certainly we can do. Now, if we watch closely, then there are two sections of the money deposition in the account. First section is person deposited amount of y0 at the beginning. Whatever person is depositing amount in the bank, every year that amount will be multiplied with a factor called a. After t years, whatever someone has deposited, that amount will become that amount into a to the power t. If he has deposited S amount, then S amount will become after T years. After deposition of S amount, after that T years, it will become S into A to the power T. Okay, can we use calculus to find everything? Now there are two streams of money. One stream of money that went into the account when time equal to 0. That is Y0. So I know Y0 will become A to the power T only. So one money is Y0 into A to the power T. What is another money? Another money is external person is depositing in the account every year, every end of the year. First end of the year he deposited S amount. That will become cumulative for T minus 1 year. Okay, next amount. So if I talk about S1, because Y0 I have the solution. That is Y0 into A to the power T. That I know. Other, if I see, then there are two sources of money that is going into the account. Two sources of money that is going into the account. One source is Y0 and one source is S. If I take S only, then S has many sections. One S deposited at the end of 1 year, one S deposit at the end of second year, third year, fourth year at the end of T year. Five means TS got added. At the end of T year, TS got added. But the last S will not get any interest. This S will get interest for 1 year. This S will get interest for 2 years. This S will get interest for 3 years. This S will get interest for 4 years. And then one more is there, that is Y0. Y0 got interest for 5 years. This S for 4 year, 3 year, 2 year, 1 year, this S will not get any interest. Okay, now I have 5S that deposited in the account. Okay, first S will become S into A to the power T minus 1, where T is the full period from the first Y0 deposition. S into A to the power T minus 1, S into A to the power T minus 2, S into A to the power T minus 3, like that, it is like that. Okay, now we have talked about that. Okay, okay, consider this is a multiplier. We have given this uh, uh, clarification. Consider this is a multiplier. If this is a multiplier, multiplier of two items. If I multiply two items, this multiplication. This multiplication can be achieved through repeated summation, and this multiplication can be achieved through the integral calculus. If I multiply 3 into 2, if I multiply 3 into 5, I write 3 into 5. 3 into 5 is same as 3 plus 3 plus 3 plus 3 plus 3, 3 5 times. That is same as 3 into x, where x is 5. Same as 3 into dx, where x is going from 0 to 5. Same. So any multiplication can be achieved through integral calculus. 3 into 5 is same as 3 into x, where x is 5, or same as 3 into dx, where dx will go from 0 to 5. Same thing. 3 into 5 can be written as 3 plus 3 plus 3 plus 3 plus 3. So if I have 3 into 5, if this round shape is talking about multiplication, then this fork is repeated addition. I can achieve repeated multiplication through repeated addition also. I can achieve this multiplication through integral calculus also. Or if I have repeated addition, that can be resolved into a multiplication, and then multiplication can be resolved into integral calculus. Means if I have repeated summation, then I can go with the solution in integral calculus. This is what the research is. I can go through integral calculus. Okay, if I have repeated addition, we are in discussion, can we divide our problem into n different parts and solve it part by part? So now we will divide our problem into n different parts. Means I have n number of s that I have deposited, or someone has deposited n number of s, or t number of s. T is number of years, small t. T number of s someone has deposited. Let's break into t number of parts. One part will become s into a to the power t minus 1. Another part will become s into a to the power t minus 2, like that. Can all these parts be same? Then it will be repeated summation. Okay, it is possible. If I bring another variable called x, so it will become s into a to the power t minus x. Another will be s into a to the power t minus x. Another will be s into a to the power t minus x. All will be s into a to the power t minus x. If this is x-axis, the first s, the first s will be s into a to the power t minus x, where x is 1. X starts from 1. This is origin. This is origin. This is 1. X equal to 1. X equal to 2x. So this height is s into a to the power t minus 1. If x is 2, then height will be little lower. S into a to the power t minus 2, s into a to the power t minus 3, s into a to the power 0, just s. Okay, but I am saying you are s into a to the power t minus x, where x is varying, but on the notebook it is same. S into a to the power t minus x, s into a to the power t minus x. How many times? X time. Then it will become s s s. Let just leave the s, because s is everywhere. A to the power t minus x multiplied by x time. Anything multiplied by x can be written as dx. 3 into x is 3 dx. A to the power t minus x into x is a to the power t minus x dx. Okay, or if I have multiplication of two item and first item is function over x, that is the second item, then blindly I can rewrite it as integral calculus. A to the power t minus x into dx. This is our proof. This is not available in any of the book. Anyone can try. A to the power t minus x dx, where x is going from 1 to t, because it will become a to the power t minus 1, that is the beginning, a to the power t minus t, that is 0. If someone integrate a to the power t minus x, it will become minus a to the power t minus x divided by logarithmic of a, logarithmic of base e, natural log of a. Okay, minus will come outside. Now, limit is x is 1 to t. If someone set the limit, let's take out 1 by log of a and minus outside. Then if someone settle it down, it will become e to the power, if it goes as 0 to t, e to the power 0, 1, 1 minus e to the power t minus 1, minus it outside, it will become a to the power t minus 1 minus 1 divided by logarithmic of a. Whereas we got through the normal computation as a to the power t minus 1 by a minus 1. Anyone can compute it, very simple it is. What is a to the power t minus 1 plus a to the power t minus 2 plus a to the power t minus 3, or 1 plus a square plus a to the power 3 plus a to the power 4 plus a to the power t minus 1. This addition will become a to the power t minus 1 divided by a minus 1. Very simple way. We have demonstrated this in past video. Okay, now we have two equations. One, we brought it through algebra, that is a to the power t minus 1 by a minus 1. One we brought through integral calculus, that is a to the power t minus 1, come down, minus 1 divided by logarithmic of a, where they are same, where they are not same. If a number is very big, then certainly they are not same. If a number is very big, then certainly they are not same. If I take only denominator, one is logarithmic of a, one is a minus 1. A minus 1 means a only, if a is very big. A can never be same as logarithmic of a. Both are completely different. If I take base of 10, then logarithmic of 1000 is 3, whereas a is 1000. There is a vast difference between 1000 and 3. If I take 10,000, then logarithmic is 4, whereas this is 10,000. There is a vast difference between 10,000 and 4. So both are not same. One is a to the power t minus 1 minus 1 divided by logarithmic of a, and one is a to the power t minus 1 divided by a minus 1. Okay, but our concept is perfect. If I have repeated summation, I can go with integral calculus where things are lacking. That we also demonstrated it in the past video. So consider this is x-axis, and let's go with the graph. If this is x equal to 1, a to the power t minus x means it will, if x is 1, a to the power t minus 1, graph will come like this. That will be a curve like this. Okay, if curve is like this, if I am going for normal addition, a to the power t minus 1 plus a to the power t minus 2 plus a to the power t minus 3, like that, then when it is a to the power t minus 1, now we have x equal to, if I see the gap between these two, a to the power t minus 1, a to the power t minus 2, gap is 1, 1. Okay, gap is 1, 1. Okay, if I take in a form of a to the power t minus x, then x is 1, x is 2, x is 3. Gap is 1, 1. And at each gap, we have vertical line. Okay, same vertical line I can write as a to the power t minus 1 multiplied by 1, that is the gap. It will form a rectangle. Then a to the power t minus 2, that will be smaller. Then multiplied by 1, that will be this rectangle. Then this rectangle, then this rectangle. So all rectangle, if I add, it will become a to the power t minus 1 by a minus 1. But if I draw a curve a to the power t minus x, then curve is like this. If curve is like this, and then if I say a to the power t minus x dx, we are calculating area underneath it. We are calculating area underneath it. Whereas in the repeated summation, what we did, we added all the heights only. A to the power t minus 1 plus a to the power t minus 2. We added all the height, or in generalized case, we multiplied with the 1, that is the width, 1 width. But here, if I take the one side, if I take the one region, that is a to the power t minus 1, and then a to the power t minus 2, in integration, it will calculate the area like this, then area like this. All area, if you add, it will become a to the power t minus x dx. X is from 1 to t. Okay, but if I take 1, that is a to the power x, and x equal to 1 and x equal to 2 between it, then vertical bar will go like this, and it will calculate the rectangular region. Whereas in our integration, we are calculating this region. So this region is smaller than this rectangular region. Rectangular region is big, and our integration is calculating this region, that is small. How these two can be same? Okay, where it matters when A is very high. If A is very high, then if A is very high, then if I calculate the A to the power t minus 1 plus A to the power t minus 2 plus A to the power t minus 3, this is A to the power t minus 1. Okay, if I do A to the power t minus 1, then this is the vertical and this is 1, consider this is 1. This rectangle we are calculating. Whereas through integral calculus, this is curve is going like this, and at x equal to 2, this height, that's it. And then there is a curve like this. This curve underneath this area we are calculating, while with the algebra, full area we are calculating. So this area is much bigger than this slant area. If A is very big, if A is 1000, 10,000, then difference will be very high. Then difference will be very high. Means if this is the curve, if this is x equal to 1, then this is the rectangular area. Whereas this is the area under integration. This area is far less than this area. If this height is even high, then gap will be even more. Okay, this is what we are saying. How to minimize it? Then we are talking about a bank who is talking about dividing annual interest into monthly interest. We divide 1 year into 12 months. Now things are becoming computational every month. We talked about a bank. He is saying 7.5% is the annualized rate, but we are calculating monthly basis, not yearly basis. Means every month the principal plus interest will become new principal amount after 1 month. Then what is your interest? Then every month you will calculate. That will be 7.5 by 12. More or less, he is saying that forget about the year completely. There is no year concept at all. If we are calculating for 5 years, then there are 60 months in it. If monthly basis we are giving interest of 7.5 by 12, whatever comes as a number, consider that number and forget the concept of year at all. If you forget the concept of year, then there are 60 years or 60 months, 60 units are there. If there are 60 units, then our computation will be different. Now it is a to the power, if I go through the normal algebra, a to the power t minus 1 by a minus 1, where a is different. Now a is much smaller now. Earlier a was 1 plus c was 7.5. Now a is 1 plus c by 12. Okay, where n is the division I make between 1 year. Earlier when we were computing x, okay, we demonstrated in last video also, but I felt I should demonstrate more on it because this is a very big thing where people can come to the calculus dividing problem into n different parts and then solve it. If I have a problem where x is going from 1 to 5 for 5 years, I am dividing it into 20 into 50 parts, 60 parts. Okay, or between x equal to 1 and x equal to 2, I am dividing it into 12 parts, monthly basis, 12 parts. So now each part is of length 1 month. Okay, and interest rate for one part is c by n. That is n times I divided my 1 year. I have divided 12 times. So 1 plus c by 12. Earlier a was 1 plus c. That is 1.075. Now it is 1 plus 0.075 by 12. It is, or I can say 1 plus c by n to the power t. T was number of year. It becomes to the power t into n because how many times I divided. So if I divide for 12 times and t is 5 years, that becomes 6t. And it is c by n, c by 12. More or less a is changing and on the top t is changing. So if I am talking about s factor, that is becoming the amount, then it is s into in bracket a to the power t minus 1 plus a to the power t minus 2. That's what it was earlier. That becomes s into a to the power t minus 1 by a minus 1, where t is 5. After 5 years I am checking. Now t is 60, t into n, because n division I make for every year, 12 division, t into n. So n is 12 now. So it is a to the power 60 minus 1 by a minus 1, where a is, earlier a was 1 plus 7.5 by 100. Now it is 1 plus 7.5 by n, that is 12 into 1 by 100. Okay, a reduced and t, that is the power that got increased. Okay, now let's tackle again. Now we have through calculus a to the power t minus 1 into the a to the power t minus 1 divided by logarithmic of a. Now logarithmic of a is 1 plus c by n, where n tends to infinity. Right now I made it 12 times 1 year, I divided into 12 times. I can divide it into 1 year into number of days also, that is the equity market they do. Divide by 365 days. I can divide into number of hours also, number of minutes also, number of seconds. Come on, man. Number of seconds in 1 year, that it tends to infinity. Means it will become 1 plus c by n, where n is number of seconds in 1 year. Every second, principal amount will change. In that fashion, n tends to infinity. Logarithmic of 1 plus c by n, where n tends to infinity, then c by n will tend to 0. 1 plus anything that tends to 0, logarithmic, if I say log of 1 plus x, where x tends to 0, it will become x1. Because log of 1 is 0. Log of 1 plus x equal to x if x tends to 0. So it will become a to the power t minus 1 by a by c by n. A is 1 plus c by n. Logarithmic of 1 plus c by n, where c by n tends to 0. In that fashion, it will come as c by n. 1 plus logarithmic, everything will go away. And then e to the power t minus 1, t will become n into t. More or less, it will become a to the power tn minus 1. A to the power nt, come down minus 1, because nt minus 1 and nt, there is no much difference. T minus 1, t will become n into t. There is no much difference between a to the power nt minus 1 or a to the power nt. There is no much difference because n tends to infinity. It will come as a to the power nt minus 1 by c by n. Now let's see what we calculated through algebra. A to the power t minus 1, a to the power t, come down minus 1 by a minus 1. A minus 1, anyway it will become c by n only. Okay, on top, now both are same. Means integral calculus works only when you have the gap between two samples tends to 0. You have gap between two samples that tends to 0. But for algebra, that's why I brought the discussion. But for algebraic equation, he is thinking that x starts from 1 and it goes. Now in the new terminology, when he is computing in new terminology, he is thinking that what we started at the time equal to whatever time we started, and it is going up to 5 years. Actually, there is no 5 years. There are 60 gaps are there. This is what the normal computation is seeing. The person who is computing through algebraic way, he is seeing 50 gaps or 60 gaps are there. Earlier he was seeing 5 gaps there. Now he is seeing 60 gaps there. That is the change. Forget years now. One thing. Second thing is A has reduced a lot. Earlier A was 1 plus C. Now A is 1 plus C by N. A has reduced. Okay, what I'm trying to say is, if I'm trying, now let's go the pictorial way. Why they are same now? Integral calculus a to the power tn minus 1 by c by n. Through the algebraic way, a to the power tn minus 1 by c by n. Both are same. So, whatever the concept we have brought in, that is called repeated addition, dividing problem into n different parts and then solve part by part. Then while solving part by part, we saw it is a repeated addition only, a to the power t minus x. Okay, it is a repeated addition only. Okay, so it worked. Why it worked? It worked in a way that the problem was coming difference in the area that we were calculating. Earlier, x was 1 and x was 2. At the 1, we have a to the power t minus x, a to the power t minus 1. At x equal to 2, we had a to the power t minus 2. But when we were doing through adding only the height, the first height was this, a to the power t minus 1. Then a to the power t minus 2, or a to the power t minus 1 multiplied by this width. This width was 1 year. More or less, we are doing a to the power t minus 1 into this width that was coming as a rectangle. Okay, what and when we are doing the integration, then we were multiplying when we were calculating this area through integration, then a to the power t minus 1, a to the power t minus 2, then there is a curve in between. This curve area we were calculating through integration. So both were very different. Now what we are doing is that now when we say a to the power t minus 1, very big, true. A to the power t minus 1, very big. Okay, but this width is very small. Okay, if I go area wise concept in the wise concept in the calculation of repeated summation, the width that we are multiplying, that is very small. First a we reduced it. Now in both section a is reduced. Second thing, this width is reduced. Now there is no much gap. If I calculate the kind of this vertical length, vertical area, if I do in the algebraic manner, if this is the if I go in algebraic manner and if this is the height, and then I keep the same height for full duration, but this width is very less. Now it is 1 month. If I take 1 second, then there will not be much difference between if I calculate through the curve area or through the vertical area. Vertical area is rectangle and curve area is a slant. If this width starts narrowing down, then there is no much difference between integration calculated area and normal calculated area, because we are chopping into 60 parts. Now if I chop into 6,000 parts, then we are adding, if I consider now if I do go through integral calculus, then we are summing 60. The curve is same. Curve is from x equal to 1 to x equal to 5. Curve is same. But if I go through integral calculus, then 60 area we are adding integral calculus, because we have chopped into n different parts. 60 area we are calculating. Fx dx, x is 1 to n, is same as sigma summation I equal to 1 to n fx delta xi, where delta xi is the width. That is, if I say, if I have integration x equal to 1 to 5 fx dx, it is same as summation I equal to 1 to 5 fx delta xi, where delta xi is the width of one section. Okay, here we are doing summation I equal to 1 to 60, because I divided 5 into 12 parts, 1 to 60 fx dx, fx delta xi, where delta xi is the width of 1 month. That is 12 times smaller than what? 12 times smaller than this. Okay, now if I go with the repeated addition, the way it is a to the power t minus 1, a to the power t minus 2, in that fashion it will go up to a to the power t minus 60, because 60 times we are doing. In that fashion, each height will, the gap between each height is very less. Means the rectangular region what we are calculating, that rectangular region is more or less similar to what we are getting through integration, because things are smaller. What I am trying to say, consider there is one region that is between one, there is only one height is there between x equal to 1 and x equal to 5. This will be better illustrated. Consider there is a curve like this. There is a curve like this, and x equal to 1 and x equal to 5. There is only one height at x equal to 1. What will be that? What will be if I say I have just a calculation called a to the power t minus 1. T is constant, or t is 5. A to the power 4. How much is a to the power 4? A to the power 4 is this big. Whereas here, if I say, then here, if I do, what is your equation is? Equation is a to the power t minus x, where t is 5. X starts with a 1. Then this height is a to the power 4. After that, there is no height. Consider. Then what will be what will be this rectangle? A to the power 4 multiplied by 4. It is as good as we have a to the power 4 everywhere. That will be a high amount. If I divide it into 5 parts, then we have a to the power 4 plus a to the power 3 plus a to the power 2 plus a to the power 1 plus a to the power 0. This, if I divide into 5 parts, then this will be smaller then a to the power 4 multiplied by 4 or 5 whatsoever. A to the power 4 multiplied by 5 or 4, it will be much higher than a to the power 4 plus a to the power 3 plus a to the power 2 plus a to the power 1 plus a to the power 0, because I divided it into 5 parts. If I divide into 5 parts, that summation will be less than if I have only one part height at the beginning and multiply by the width. Same concept we are applying. Now we are chopping into 60 parts. If I chopping into 60 parts, then multiplying first part by 60, it will be much less if I add all 60 parts, because it will go smaller. It will become more fine, then finally it will come to integral calculus only. Anyway, this is a concept that we are pursuing, dividing problem into n different parts and solving part by part, where each part is same, a to the power t minus x. Can we corroborate this? Can we? Now someone would say, can you use another technique? What do you want by another technique? Can you use another technique? What do you mean by another technique? Another technique is when we are calculating the area. Consider this is x equal to 1. This is x equal to 1. Yeah, this is x equal to 1. Consider this is here, there is any x. Yeah, this is any x. At any x, we have a height called a to the power t minus x. Yeah, a to the power t. And at any x, height is a to the power t minus x. If this is x, then next is x plus 1. Yeah, next is x plus 1. Then height is a to the power t minus in bracket x plus 1. Yeah, that is the height. Then what is the area in between it? What is the area in between it? Okay, area in between it. So area in between it is if I go by rectangular fundamental, then area in between it is a to the power t minus x1 multiplied by 1. The area is a to the power t minus x multiplied by the 1. Okay, that is the area. Okay, no, I'm talking about integral calculus. If it is integral calculus, then what will be area in between it? What is your formula of integral calculus? What is formula of normal summation? Normal summation formula fx is a to the power t minus x. At any x equal to x, the height will be a to the power t minus x. If I calculate the area of between x and x plus 1, that area will be a to the power t minus x into 1. But that area has to be same as if I calculate the area in the integral calculus. Then that area cannot be same if you again take fx only. Fx is a to the power t minus x. That the area between x equal to x and x plus 1 is a to the power t minus x into 1. That area I'm trying to get same area by integral calculus. Then you have to have another function called gx. What you are trying now? I'm trying fx into width. Fx is a to the power t minus x into width, that is 1, equal to gx dx from x equal to x plus 1. If I get this, then I will get another gx function. That will come as a matter of integration. Now I can take that. So this is called discrete function fx, and gx is called continuous function. Discrete function where I have a height, only height. All the height, if I add, I get the result. Whereas in continuous function, I have to calculate the area to get the result. Not only addition of height will work. So if I have a discrete function as fx, then what will be continuous function gx? So that gx dx between x to x plus 1 will be same, that area will be same as fx. We will proceed in this concept also, and then we will tackle this dividing problem into n different parts and solve part by part. These are explicitly not available, exclusively not available in any of the books. Please do not mind supporting us. +91 is the India country code 9483160610 is a telephone number. +91 is India country code 9483160610 is a telephone number. Similar thing we have already demonstrated in the past also. But as far as correlation between what we showed and this, that is unique, and that we will tackle it.